This is Algebra 1, Lesson 53, Power Rule for Exponents and Conversions of Volume. Alright, here I am in Golden Valley, Arizona. Temperature's about 62 and it's December 4th. So a friend of mine let me know that in Sterling today it was 0. So I'm sitting out here on the deck in a short sleeve shirt lecturing Algebra 1. So anyway, let's do the power rule for exponents. Alright, so when we have an exponent, meaning when we have something like x to the 5th, and we multiply that by x squared, that is the same as x to the 5 plus 2. When our exponents are on the same level, when they are right like that, you add them. When you have an exponent that is here, and then you make a parenthesis, and then you put another exponent there, notice they're not on the same level. One's higher than the other. Also, there's no multiplication sign. All there is a parenthesis between the two exponents. So those are your couple keys of saying when that is the case, you multiply the exponents. And it's 5 times 2. Because what does this mean? That means 10, x to the 5th times x to the 5th, which means if you add those, you'd get x to the 10th. Or if you just multiplied 5 times 2 here, you get 10. And that's pretty much the power rule. Not really a whole lot to it. If I give you x to the negative 7 to the negative 7, again, there is a parenthesis here. Sorry about the dogs in the background. They must see a rabbit. There was a wild horse running through the yard earlier today. We're going to multiply those. So negative 7 times negative 7 is positive 49. Okay. If I have m to the negative 2 power to the 4th power, that's going to be m to the negative 8. So you're just going to multiply like you normally do. So nothing really weird there. Let's look at a couple of examples on page 216 as far as what they're doing there, because they're making them a little bit more complicated, but if you follow that rule, everything stays the same. Y to the 5th over z to the 4th, in parentheses, a negative 2. Alright, so what happens with this negative 2? This negative 2 is applied to the 3, the x to the negative 2, the y to the 5th, and the z to the 4th. Everything in the parenthesis this is attached to. Okay, so let's look at just the negative 2 on the 3. Now you remember when you have a negative sign, that means everything is in the wrong position. Well, we're not going to worry about the letters being in the wrong position, but we do want to look at the number, because we can't take 3 to the negative 2. But if we put the 3 down here, the negative 2 goes off. Now let's take this times this, and we get x. Negative 2 times negative 2 is 4. Then we take the 5, and then we look down here. 4 times negative 2 is z to the negative 8. And if we want to switch things around, we could make everything positive, but that's not what they're asking us to do here. But let's at least take the 3 squared and make that a 9. And on the top we have x to the 4th, y to the negative 10. Now if we did want to make all of our exponents positive, we would take that and put it down here. And we would take the z to the negative 8 and make it a z to the 8th and put it up here. And so there would be our answer if we wanted everything positive. Alright, well, let's keep going on these. Let's look at the part B of the example here. And we'll just keep practicing. 2a to the negative 2b squared z to the negative 10. And we're going to take that to the negative 5 power. Alright, so what do we know here? We know that our 2 is actually a 2 to the 1st power. we know that we're going to multiply this times this, 2 to the negative 5. So let's go ahead and write that. And then we're going to multiply our negative 2 times our negative 5 and get a positive 10. And then our b squared to the negative 5 is going to be b to the negative 10. And then our z, negative 10 times negative 5, is going to be a 50. So let's go ahead and put the negative exponents where they should be. So this 2 is going to go on the bottom, so then it becomes a positive. The b goes on the bottom, so it becomes a positive. We still have a to the 10th, z to the 50. And we're going to change the 2 to the 5th to a 32, b to the 10th power, and then we'll have our a to the 10th, z to the 50th on top. And we are done at that point. All right, let's look at letter C. Get rid of this. All right, so we have 4xy over m to the negative 2, and we're going to square that. So this becomes 4 squared x squared y squared over m to the negative 2 times 2, negative 4. And if we wanted to move this 4 up, or the m up, we would just make that 4 positive and it would leave the denominator, because again, that negative just means that whatever's in front of it is in the wrong place. That negative just means that it should go in the numerator if it's in the denominator if it happens to be in the numerator. In this one here, it was in the denominator and it was negative, so to take the negative off, we had to move it up. All right, let's try the next one. 3x to the 0 power y over k to the 4th power, and we will put that in parentheses with a 3. So 3 cubed x to the 0 times 3 is 0, y to the 1 times 3 is 3, over 4 times 3 is 12. Whenever you have something to the 0 power, it just disappears because it's equal to 1. And the only thing we're going to do is we're going to take 3 times itself 3 times and get 3 times 3 is 9 times 3 is 27. So 27 y cubed over k, to the 12th. And that would be our answer. Alright, keep plugging along here. Sorry about all these examples, but there's going to be some in here that are a little goofy. So I'm just trying to keep that from happening. So 3xy negative 2 over p to the 5th, parentheses, negative 2. Okay, so I have 3 to the negative 2, x to the negative 2 times 1, y to the negative 2 times negative 2 is positive 4, over 5 times negative 2, and I get that. Okay, this especially, I can't have a 3 or a number with a negative exponent, so I'm going to move it down. Do that in red. Negative goes away. That goes away. In fact, we can actually, instead of 3 squared, we can write that as 9. And you can leave it like that, or you can put the positive exponents. We're going to move the p to make it a positive 10 by moving it up. And we'll make the x a positive 2 by moving it down. And you get that. Alright, so let's look at one more in this, and then we'll go to something else. So we've got 2 to the 0 power, x to the negative 2, y to the 4th, over z. And we'll put that to the power of 15. So that's going to be 2 to the 0 times 15. 0 times 15 is 0. X to the negative 2 times 15 is negative 30. Y to the 4 times 15 is going to be 60. And then z is going to be to the 15th power. Now 2 to 0 power goes away because that's 1. And that gives me x to the negative 30, y to the 60 over z to the 15th. And I'm done, unless of course I want to move that down and make it x to the positive 30 by moving it to the denominator. Okay. So that is it for that. Let's go real quickly into conversions of volume. So it says use 3-unit multipliers. You don't really need to worry about that, what that means, 3-unit multipliers. Just remember that they want you to convert 180 cubic feet to cubic inches. So cubic feet to cubic inches. Alright, so what we're going to do is we're going to write 180, and we're going to just write it as feet cubed over 1. And remember, conversion times line. But because there's a 3 there, remember when we were doing squares, we would do times line, but because there's a 3, we do it 3 times. That's the only thing. You know, you see that 3 up there, right there, and that just means automatically you make 3 lines. And underneath the line, since we have feet up there, we put feet down here under all 3 of these. Do we know anything about feet and inches? Yes. There are 12 inches in 1 foot, and we just do that 3 times. And when it says 3-unit multipliers, that's what it means. We're using 3 lines there. Okay. So in this case, we cross out 1, 2, 3 feet with these 3, and we're left with inches cubed. We're left with inches cubed is our ending, and that's what we're looking for, so that's a good thing. Multiply 180 by 12 by 12 by 12, and we're just going to leave it that way. 180 times 12 times 12 times 12 inches cubed. We're not even going to do the math. You don't need to worry about doing the math there. Alright, so let's try one more, and we will be done with this one, or this lesson. I'm hearing weird noises out here in the desert. It's kind of crazy. There's wild donkeys up in the mountains braying. There's coyotes hollering. There's quail. There's bunnies. There's all kinds of stuff out here making noise. It's kind of freaky when you're sitting here doing these and you hear all these weird noises. Okay, 800 cubic centimeters. So centimeters cubed. And we are changing that to cubic feet. So centimeters cubed to feet cubed. So we draw our line, draw our line, draw our line. Centimeters, centimeters, centimeters. Do you know anything about converting centimeters to feet? I don't. But I do know that there are 2.54 centimeters in 1 inch. So I'm going to convert my centimeters to inches, because then at least I got it from metric to the English system. And then I can cancel out my 1, 2, 3 centimeters with those 3, but that's not what I'm looking for, is inches. So I draw my line, do 3 of them again. And what do I know? Can I change inches to feet? Yes. So I put inches, 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 and there's 12 inches to 1 foot, 12 inches to 1 foot, 12 inches to 1 foot. And my inches cancel here. So then I cancel my 3 inches with these 3 inches. Feet is what I'm looking for, so I know I'm done. So I have 800 over 2.54 3 times. You can either write it 3 times or make it cubed. And a 12, I can write it 3 times or write it cubed, doesn't really matter. And that is the conversion from cubic centimeters to feet cubed. Okay, I'm not going to have you divide that out either. Alright, so that's it for lesson number 53. We are at the end of our video time, so I'm going to go ahead and shut this down. But these examples should get you through the lesson. I don't really see that there's anything weird going on in the lesson there, so you should be fine.